Hello, my name is Japri Singh Sethi and I'll demonstrate you how to build a model on SAS Enterprise Miner. The very first step is to create a new project, which is file new and project. I've already created it with the name of data mining 1, and next we'll create a new diagram, which is create diagram, or I've already created it with the name of online news popularity. Once this is done, you'll get a dashboard which will be totally blank for you. The very first step that you need to do is you need to import a file, which is your data set. This box is available in your sample file import, and then you need to change the properties, import file, and you need to specify the file from your my computer browse, specify the file. You can preview it if you want, and then you just need click OK. Next step that is very important is to edit the variable, and then you need to specify which one are your input variable and which one are your predicted variables. So here, since my data is trying to predict which article is will be popular in the future and which article is not popular in the future, so it's a yes or no sort of a output variable, so that's why it is binary, and it's a target variable. Or few of the variables which I think are not relevant are shares, time delta, and URL, so that's why I've marked it as rejected, and all other variables are my input variable, which will help me in prediction. Their level is interval because it's a numerical value, and the difference between the two value makes sense. So once this is done, you just click OK and move on to the next, which is Start Explorer, and then you just run it. Since I've already executed it, I'm directly moving on to the section which is results. In that, I can see that few of the variables are very important. Here we see that there are no missing values, so we need not to do imputation, and mean, standard deviation, and all those things are there. So next box that we need to focus on is the data partition. Here this box is available in sample, the second box, data partition, and here we specify that 70% is training, 20% is validation, and 10% is test. So once this is done, the whole process data is passed to the control point. The purpose of this is to when we need to pass the data to a multiple nodes. Nodes as in, one is the decision tree, one is the gradient tree, when we want to split the data and pass it to the different nodes. So that's why a control point is used. So we are trying to build a model. First model is a decision tree. So here the model and then decision tree, and in decision tree we are specifying probability f, which is the probability of the s distribution for the interval target criteria, and that's what we are only concerned about because our data is only interval values. So next is the depth, which is the level 6. I have selected it as 6. The leaf size of 5, which means how many minimum records should be there to create a leaf. Then number of rules is equal to 5, which means how many rules should be considered before creating leaf. 5 will be considered, but only 1 will be used. So once this is there, we need to run a model. I've already executed it, so I'm directly moving on to the results. In the results section of the decision tree model, we can see that a tree is created. It has 6 levels: 1, 2, 3, 4, 5, 6, and for each variable there's a like criteria on which it was split. KW max min, if it is less than that, a tree is there. If it is more than that, then a tree is there. Then we can see a misclassification rate, which is 34% on train, 35% on validation, and 36% on the test. So there's a tree map as well, which looks quite wonderful. And there's a output. In the output text, we can see a classification table is there. True positive plus true negatives gives a classified rate, and false positive and false negative gives us the wrongly classified rate, and this is done on the train as well as on the validate. And apart from that, we can see other important parameters on which you can assess the model. So moving on to the next one, we will be comparing it with the gradient boosting, which is taking many weak models and boosting it to a stronger one. So it is basically an ensemble of weak models. So this is right here in the model section. This is done by resampling, and this is like 60% of the training we are using it, and we are doing 50 iterations of the data to do a resampling, and this is executed using the run. And since I've already done it, so I'm moving on to the results. In the gradient boosting, we can see that the classification misclassification is 34% on train and 34% on the validation, and also 34% on the test. So this is much better than the decision tree. Looks like here we can see the variable importance. Few of the variables seems to be quite important in contributing a lot in the model. Once this is done, we'll passing it to the control point, because again we are getting an input from multiple points. So, and this is passed to a model comparison, and this is available in assess. We need to run it, and since I've already executed, so I'm directly moving on to the results part. You can see that the model comparison is between sensitivity and specificity. It's the baseline model, gradient model, decision model, and we can see that the gradient model is performing very well. The greater is the curve towards this point, better is the model.